Oh, I'm so sorry. Yeah. Okay. Now is it better? Can you guys hear me well? Yeah.
Oh, it's way
I think
better. Thank you very
the
much.
idea was to have it unmuted, but of course, yeah, it's not a proper Zoom talk until someone tells you you're muted. So but you didn't miss much. I was still just making jokes, and so maybe what you miss is that his work I'm doing with Alex Shkolnik from Santa Barbara, and Steve Lee, who was a master's student there. He wrote his thesis on another project, and now he's a pre-doc student at the University of Chicago. So I can say that I have a co-author from the Chicago economics. And so we set ourselves the task of putting the Keen model, testing it with data, and the motivation was work that I had done. Okay, now it's frozen. There we go. This is just the outline, so we can skip that. The motivation was work that I had done with another master's student who then went to do a PhD in Santa Barbara. So that's the connection. So he went there, and then Alex was talking to him about the work that we did, and we decided to extend that work to the Keen model. But we did work on the Goodwin model. So you guys are very familiar with the Goodwin model, so I'm going to go over relatively briefly. But the parts, if you are very familiar with the model, the parts that you should concentrate here are the ones highlighted in red, because those are the modifications that we introduced in the Goodwin model, because the data demanded that we introduce those modifications. And that's going to be more or less the philosophy that I'm going to adopt for the Keen model as well. We're going to start with the Keen model as proposed, and as we face difficulties that are presented by the data, we're going to suggest modifications of the Keen model progressively to address each of these difficulties. So you're familiar with the notation there. There's a labor force that it's assumed to grow exponentially. My convention is that whenever there's a bar on top of a letter, it means that it's a constant parameter. If there is no bar, it's time dependent. So n as the labor force is time dependent, but it depends. And of course now I'm already broken my convention. N0 is also constant, was the initial condition, but maybe it's not a constant that we estimate. It's a constant that we get as an initial condition. So beta we estimate. A is the productivity per worker, and it varies in time, again in an exponential fashion. And alpha is the growth rate that we also estimate. And then there's the production function, which is just the product of the productivity per worker times the number of workers. Or if we assume that this is at full capacity utilization of capital, this is just capital K divided by the capital to output ratio, which is also assumed to be constant and estimated this new bar. So the other assumptions are the structural assumptions in the model. So it's what connects the different sectors there. And so one of them is how wages are received by workers from the firm sector. And W is the wage per worker. And the assumption there is the rate of change of wages is a function of the employment rate. And that's given by the Phillips curve, which we will specify later. We'll have some constants that are also to be estimated from data. Now, the Goodwin model originally stated would say that the investment is just all of the profits. So in this context, the only two sectors are workers and firms. So what is outside of the firm sector is paid to workers, and what remains in the firm sector is deemed to be profit. So that's just production minus what's paid in wages. And the assumption on the model is that all of that was invested. And so there was no K bar in there. And conversely, the consumption then was the accommodation variable that you would consume, the workers would consume everything that they receive in wages. So we're going to see very soon that that was not satisfied by the data, not even close, not just because it was a simplifying assumption, it was like a completely wrong assumption. And we were extremely pleased when the referee actually suggested a simple fix. So this is one of those cases where the referee is very useful. So, and we credit the referee for the suggestion. And actually then estimating this ratio of investment to profits. So it turns out that investment is not all of profits. Investment is a fraction of profits only. And just introducing that fraction K bar improved the fit of the model in a almost unbelievable way. And but then so we rephrase the model in that way. And the first thing that then you have to say is, okay, if a fraction of profits only is invested, where does the rest go? So it's just a two sector model. So the rest has to go to workers. So it goes to workers in addition to wages. It goes to workers as dividends. So the household sector, which comprises of all the workers, is the owner of the firm sector, and they receive those dividends. So exactly the remainder of that, one minus that, goes there, and then because it's an accommodation variable, consumption has to take care of all of the dividends that are made. So this was our stock flow consistent check for that empirical fix of saying that investment is a fraction of profits would still be compatible with the larger framework of embedding the Goodwin model as a stock flow consistent model. So this is the stock flow consistent table that I mentioned, and we added the dividend relationship in there. And then let's see how it does with the data. So you all know how to derive the model now. You look at the state variables as being the wage share and the employment, look for the changes in that, so the dynamics for those two variables, and it just comes out as this two-dimensional system, which is still isomorphic to a Lotka-Volterra predator-prey system, now just with a different constant in there. So I'm tracking, what the effect of that simple empirical fix is to the model. It also changes so here's the Phillips curve that I promised is just, we assume is a linear function of employment. You can do more sort of theoretically sophisticated Phillips curves. Turns out they don't improve the empirical fit too much. So we went with the linear Phillips curve anyways. And the effect of the K constant was just to divide the capital to output ratio here by K, if you just follow the math of what the equilibrium should be, and it also then changes what the growth rate of the economy is, but it's still the case that once you substitute what this is in terms of the previous constants that we had there in terms of the equilibrium investment, so to speak, that it still turns out to be alpha plus beta, which is just the population growth plus the productivity growth. So it doesn't alter that relationship, it just comes here in this intermediary step. And if you have done any of these comparisons of Goodwin with data, you see that this is good news, because it's often the case that the empirical capital to output ratio turns out to be too large, quote unquote, for the model to work. And then introducing that K, no, wait a second, it turns out to be too small, because that K comes up as a fraction between 0 and 1, and putting up the K in there fixes the fit in the right direction. So let's just see how this is done. So this is just a theoretical trajectory for the Goodwin model, which of course is not going to resemble exactly what data does in reality. So the first person who looked into this was, and this is just not the phase space, this is just the trajectory as following the time evolution of both employment. So it's just this nice cyclical pattern, and the wage share, and then how output grows with an exponential trend, averaging around alpha plus beta, but with the fluctuations in each of the cycles. If you look at data, so before we look at data, what is the procedure that we want to do? So this is different, for example, from just looking at, it's different from many other procedures, one of which is how DSG models are calibrated. The other way in which this is different is, I know Florian, where is Florian? Why is he not here? Doesn't he live here? Yeah, but it's just a short walk. He should have come here. The work that Florent did with the Goodwin model was also different from this, which was to look at the parameters that come in the model and look at the actual equations, the dynamic equations, and then estimate using some stochastic version of the equations, estimate what those parameters are. And so that's a valid philosophy, but it's not the philosophy that we're taking here. We're taking the philosophy that was used by Harvey and first of all, because we wanted to be consistent and see how to compare, but also it's because it's the philosophy that I actually believe in, which is that, you know, there are assumptions made by the model about the meaning of these parameters as primary relationships, the relationship between wage share and employment, the relationship between investment and profit, and so on and so forth. And you estimate those parameters independently from the model. You estimate them from just data, even if you didn't know what the trajectories of the model were. Then they imply a certain value for the equilibrium points. For example, they imply what the entire trajectory is going to be, but the simple test that Harvey proposed was they imply some equilibrium. But also, and this is specific to the Goodwin model, because of the cyclical nature, it's a closed orbit and it just, you know, moves around. So it turns out that the time average of those variables is the center of those trajectories. So you can just look from the data. If the data were to follow the Goodwin model, then the time average of the empirical observations would have to be somewhat close to the equilibrium value that is presented there. So that's the test. Do they look like they're close? And so this is what we're looking at for different countries, for the wage share and employment rate. There's a values for the time average of the wage share in the sample that we had, which was 1960 to 2010. And now it's just a simple verification. Do the equilibrium values plugging in the estimates of the parameters match these values or not? And when so now I'm just saying how to estimate the parameters. We don't need to get in too much detail here, but some of the parameters are assumed to be constant, so they're just estimated as their own time average. Some of the parameters are done by regression least squares on, for example, exponential trains, and you just take the logs. The tricky ones are the parameters in the Phillips curve, because neither of the variables here are stationary at face value. You need to check, and it turns out that they are not stationary, but it turns out that the degree of integration of those variables allow you to apply a bit more sophisticated tests to see if there is a stable long-term relationship between the variables, even though they are not stationary. And that stable relationship is what you estimate here. So it turns, if you just run the regression, it's the result that you obtain, but you need to do a lot of work to justify why the hypotheses are satisfied by this particular time series for lambda and for the rate of change of the wage rate. Okay, so this is just to justify that an exponential productivity growth is plausible. There's the exponential trains, and there's the productivity growth that we see. This is for the labor force. So again, for that beta estimate. But here is why we needed this accumulation rate K, because if you just calculate 1 minus omega, which in this model plays the role of profits, that's not even close to what investment is. It's visibly biased, and so we just now take the ratio of this two time series at each point and take the average of the ratio and estimate K bar. Now, Harvey didn't do that, but Harvey also didn't do things correctly. So there's a famous mistake in the paper in translating data from one table to another that made even his results look worse than they should be, and what he obtained is that, you know, these are the estimates for the equilibrium and these are the trajectories. So evidently the equilibrium is completely outside of any average of the trajectories, and then he just said Goodwin model should be put in the garbage can. And then we kind of resurrected that first by correcting the translation mistake, the transcription mistake, and that made things much better. And there was a paper that we sent as a correction to the Cambridge Journal of Economics. There's a funny story on that I can tell over lunch. And then we sent the fuller paper where, in addition to the correction, we made our own modification of the model. And so these are the estimates that we obtained for the model, and you can compare with values found in the literature for this growth rates, and they're all compatible with what you find there. The capital to output ratio is also not out of range with what other authors have found, is of the order of 3 for many different countries. The depreciation rate is also what you find in tables of depreciation of capital. The parameters for the Phillips curve are also not out of line with what other authors that were just considering Phillips curve they found. So everything here is unsurprising. But the novelty is this K. So it turns out that, you know, depending on the country that you're looking at, it's something of the order of, you know, from 60 to 80, 90% of profits that are invested, not full profits. So evidently, if you just constrain this to be 1, you're going to be making a lot of error in the model. Allowing this to be estimated and correction, then the model gets better. It's 1 more parameter that you estimate. We also calculated the, you know, information criteria in there. The gain that you make in the goodness of the fit for this, it's far outweighs the fact that you're just introducing 1 more parameter to the model. So these are the things that now the equilibrium rates look like. And if you plot them, you start to see that, you know, our equilibrium rates are now kind of at the center, close to the center of the trajectories. Well, you know, some countries are better, like there's you take the average of those things and you get something close to the equilibrium point. For some countries it's worse, the average. I think that's the United Kingdom. So there's something weird in the United Kingdom, but the, you know, as the French say, tant pis, we knew that, right? Yeah. But so we were content with the results that we got there, but we knew that there was more work to be done. And reassuringly, so to speak, the worst results were for the fit to the wage share, not for the employment, because the employment, the equilibrium values, if you come back here, for the employment, they only depend on the Phillips curve and the productivity. And we felt that we couldn't do much better in there. But the equilibrium value for the wage share is what depends on the shape of the investment curve. And because we know that the investment in the Keene model is the most sort of rudimentary assumption, we thought if we improve the model, for example, by going to the Keene model, there's a potential to improve in the fit for the wage share as well. So that's the motivation. So any questions on the Goodwin part? Because now I'm going to switch gears. Oh, and so we had some of the phase space diagrams there, and these are the actual trajectories. So you can see that, you know, the Goodwin captures where it is. It captures the level of what the actual time series is. It captures some of the fluctuation, but it doesn't have the capacity, for example, to capture this downward trend that you even more pronounced, a downward trend for the wage rate that you see in many countries. It just stays at the same level because it is that cyclic and stationary thing. So we feel that, you know, it's not too bad. It's not sort of completely wrong, but there can be nuance added to the model, both to have better fit to the fluctuations, but more specifically a fit to time trends. And that's exactly what the hope was for the Keene model. So I will stop now and get questions. Yeah, go on.
So on everything that has been said.
You can ask questions about everything that has been said, but maybe you can even ask questions about the future, but yeah.
Don't worry on the additional parameter. We were having this discussion yesterday with Frederick on data. That actually, yeah, it makes sense. What seems to matter dynamically is what part of the income is actually invested, because that's what determines the rate of growth of the production capacity of the economy is shrinking suddenly, which explains lower rate of employment for the next exercise. And then we have this cycle, so we were discussing that. So the question I wanted to ask, maybe you said it, but I tried to write the question of at the same time.
Yeah.
I just wanted to know, because actually, so you showed the data. We have the data of what part of the income is invested. They are also as easily accessible as the data concerning profits and wages.
Sure. But we have
two different things. One is by having very simply the data on investments and profits, and the other thing by
yeah. So I think we did look into that, but the definition for that is completely different from what is in the model, right? Because what counts as profit in that is very different. And I mean, investment is the same thing that we're getting from the national statistics, but yeah, the definition of profit is completely off. So we wanted to do it in the context of the model, right? What is the proportion of this definition of profit that would go into investment, right?
Okay, so it does seem to match very well because of that.
Yeah.
Okay.
Yeah. If the other one is just that profit will include all sorts of things that we are going to talk about in the Keene model as well, like taxes, dividends, things like that. Yeah.
Two very short questions. First, to be quite understand is decide to not estimate all parameters. There is some that you just plug in. So for new, for capital to output ratio, so for K, for instance, you not estimate from data.
We do, but we do an estimate as an average. So we take the time series of those ratios and we take the average of that time series. So we are estimating a regression against no explanatory variables, so to speak, as an average model.
So in your Goodwin model,
yeah,
parameters associated. So here, for instance, you use from maximum likelihood or
for alpha and beta, yes.
for alpha, beta,
yeah.
but for K.
So K we have 60, 50 observations for K. We take the average of that.
Okay, not from the weight share and longer observation. You don't estimate it from this.
No.
You estimate from another.
Correct. Which is the whole philosophy. So we never use the state variables and try to minimize the error on the state variables in order to find the parameters.
And so why you don't? Why? Just a question.
Because that would mean that we are kind of ignoring the economic motivation for that variable and just saying that it is a parameter in the dynamics that is free from its own economic meaning and is just adjusted to the error in the dynamics, right?
You can constrain these estimations to be
well, sure, but what I mean is that then how does that compare? Because you know, if I estimate the K by minimizing the error in these trajectories here, right, and then I find a value of K that it's I don't know 0.2, right, something, right? What does that tell me about the underlying definition of K, which was, you know, in each year you see what fraction of the profit that you're observing go into investment. So I have an entire time series for K up here that is hovering around, you know, 0.8 or 0.7, And then the estimate that the model tells me that it should be is 0.2. What is that telling me? It's just telling that the model is wrong. It's just saying that, I'm forcing the model to match the observations of the trajectories by artificially moving the value of a parameter that I know is in the wrong ballpark. Right? Could be just the same for the capital to output ratio, just saying, so sure, what if the model tells me that the capital to output ratio should be 8? Well, we know the capital to output ratio is not 8. You can look at the observations year by year. There's not a single year in which the capital to output ratio is 8. Right?
I'm sorry.
The model behind that not reflects.
Correct. So what the
match with your
So what the philosophy here is that we don't believe in the model. We want to see if the parameters are estimated from their original meaning, and there's an independent way of estimating the parameter, right? So if anybody says, what is the capital to output ratio for the United States? You go around and you look at capital data and output data, and you estimate the capital to output ratio. You don't say, oh, the capital to output ratio for the United States is the value that makes the trajectory of this model minimize the error. No, right? So you just go and estimate the capital to output ratio. Yeah.
Just on this, nevertheless, the fact that we take the average over time, it says something about the fact that we know that it should be the average according to a good model, isn't it?
No, so the average is the sort of a minimal assumption model if you want to say that that's constant. If the model, if you assume that, so okay, you are now it's an assumption that would be either true or not statistically, but not because of the Goodwin model, right? So this is a simplifying assumption, just saying it is constant, and you could then calculate, what is the goodness of it for something that is doing this, for example. And you assume that it's constant, it's not going to be good, right? And so that's the motivation philosophy, that we look at each of these relationships as much as the statistics is telling you for that data, and not what the model should be telling.
Yeah. After that, you talk about goodness of it.
Yeah.
And so you say that when we move and so fix k equal 1 to k equal different.
Yeah.
The goodness of it is better. So
correct.
you look at it with the truth, with the observation, with the data.
Yeah.
So it's in a given way you are saying that you are comparing with data.
Yeah.
But we don't want to.
I don't want to impose. Yeah. So it's like this model, if I use a more sophisticated version of the relationship between investment and profit than it was in the original model would force k to be 1, would not allow me to estimate the k, and it would have worse errors. And that's a conclusion for that model. And I'm not going to change that to adjust what k is. Now it's a new model. It's a Goodwin model with with not a varying k, with a non 1 k. Yeah, with a k not equal to 1. That's a different model. And then all I'm saying is that different model has better performance. But it's not the performance of the model that is dictating what the value of k is. The value of k is also estimated separately. I'm just saying that after estimate, the model with a non-constrained k performs better than the model with a constrained k.
But if you estimate it with the data and you have 0.2, for instance, it could be better.
The model would perform better, but I would say that that's kind of cheating, that you're treating that not as an economic parameter, you're treating that as a free parameter in the model. You're treating that as a slack variable in the model. You're just saying the model has that free parameter. I don't care where it comes from. I'm just finding the best value of that parameter, which is a lot of what the DSG literature does, right? By introducing all sorts of shocks that are not estimated to the original meaning of the shocks. They're just postulated. There are some shocks. The shocks introduce a bunch of free parameters. Let's find the best value of those parameters that make the DSG model error small. Right? That philosophy I don't want to follow. Yeah.
Can you show the plots with the fit of the weight share?
Yep.
Very quick. I have two questions remaining. The first one we can skip and talk about it later. It's the usual problem. The cooling cycles are profit-based. But if we believe in the process of development, then higher wages would mean higher effectiveness, actually growth instead of. And that's something that, and I think there have been some paper by Bonner comparing the William to Pedestrian models and estimating that they did it on over a few European countries, and apparently they observed that the Pedestrian models were performing better. And there's also something else, which is that there are other mechanisms that will apparently allow you to generate cycle of approximately the same frequency. So you could do it as well with similarly realistic parameter, but I don't know if they ever did this model logistic.
Right.
And some paper by Stockenberg called pseudo Goodwin cycle in the Minsky model.
Yeah. Yeah.
And it's so the cycle are generated not because of the classical inputs of the distribution of the curve, but because of the so Minskian cycle, the enterprise borrow money.
Right.
The more they get in debt, the more they increase their financial fragility. So the banks lend less for the next exercise. And that's all they apparently managed to generate.
Yeah. Yeah. So that ties with the previous discussions that I have. So now if there's a competitor model, so this is all in the context of the Goodwin model. And the only thing I'm saying is that this sort of more refined model performs better than the unrefined model. But now put a competitor model there. And the competitor model might be related to the same basic economic relationship. So the estimates should be the same for both. And then I need to feed those estimates to both models and see what the errors are. And I should not be allowed in one model to treat K as a free parameter, and then in another model treat something else as a free parameter, and then fix them so until the errors of those models are comparable, right? Yeah.
And I wanted to see this again because I want to make another proposition beyond handling that.
Yeah.
Which is to actually remove the trend, because obviously it cannot be explained by the simple equation or original model.
Right.
It can only explain the fluctuation around the trend, which is assumed to be given constant, cannot be explained by and I know because I'm working on that, I'm trying to explain why there's been a slowdown in growth and why there's been a decline in the wage share.
Right.
This has been observed, so it will be in the data.
Yeah.
So actually, it would make sense, and it would not be cheating to say that the Google model only explain the fluctuations.
Right.
So I want to fit it to the fluctuations around.
But now you need to redefine the model, right? So it wouldn't be a dynamic equation for the wage share. You need to redefine, and it might be that it turns out to be like very similar in shape, but I haven't seen the derivation. So you need to define a state variable, which is whatever the wage share is minus a trend, and follow the derivation of that for the dynamical system. And it might be a similar model, but I don't know that. Yeah. But hold that question, because
or maybe it can even be on the data
Oh, no, but now now again, you're modifying the meaning of the data to to fit a model that was not derived for that. So I would be careful with it, right?
Yeah, if you do this, when you get the average one of the parameters, then it's completely.
Yeah.
The whole point, I mean, just to rephrase it.
It cannot fit. I mean, see
Yeah. Yeah.
I think the whole, Matheus, the way I understand it is to say, let's take the viewpoint of the thesis, and when you build a new theory, you don't change the constant of Planck.
Yeah.
It's given to you.
Yeah.
So what you do essentially is to say, well, there are a number of constants that I should be able to estimate because we are not in physics, but I estimate them completely separated from the model. And then I check them.
Yeah.
So that's
That's it.
approach.
That's
It's
it.
completely different from the one taken by Florent.
Yeah.
Which tries to, as you said, to optimize the various variables, given some stochastic process that he assumes underlie
Yeah.
data. So it's a very different.
Let's say I don't want to have that much flexibility, but you can just remove the trend acting one parameter.
Sure.
It is
Yeah.
like you did with Docker. Just one extra parameter
Yeah.
will work so much better. And I think that it also makes sense because the phenomenon between the trend is not the same phenomenon between cycles that
Yeah.
you are trying.
So I would say I would like to see that, but I haven't seen. So I need to see what the actual derivation of the model is, and then where it does that. What explains that train parameter if there is a model underlying that as well? Yeah. So.
First to answer to that a bit, I've tried on the key model, typically because you have a shift of the trend and you have just cycles of it, and we can decompose both and study both different in different manner. So that's perfectly possible to do that even on a simple Goodwin key model, and we can do that for other models. I just had so first I really appreciate that you're trying to do a reality check of everything which is measured in the real world,
Yeah.
compared to this abstract construction that we've created model, because I think it's really what is needed to be sure that we are consistent with reality. So really thank you for using that type of approach. I really like it. I had if we try to go a bit to push even further the Goodwin model, it's also giving us the nominal or kind of nominal value for the consumption and for the investment.
Right.
And from what I see in your modification with K, you should have under investment in nominal value and overconsumption in nominal value compared to the wage.
Right.
Is it the case? Have you checked? And
So we did. So there's a version of the Goodwin model with nominal, and then there's an equation for inflation that can come in, and it does. So that was done by Desai and others, and so we did some of that is in the appendix of the paper, but we didn't explore, the further economic meaning of this under consumption over investments and things like that. That could be something to be done. But at that point we said, okay, well, our real interest is to move to the Keen model. Why? Because we think that there's something to be said about private debt, and there's no private debt in the Goodwin model. So sure, there's an entire cottage industry of improving the Goodwin model in one way or another, and people can go into that, and I encourage them because I think it's a great little model. But I wanted to go into the Keen part, which would start soon.
Just two very small things. It's just my question: if we don't see this on overconsumption and the investment, it could be also a move of capital away.
Right. Which is another extension of the Goodwin model that people did, like a Goodwin model connected to a different country and things like that.
Which might explain why some countries.
Yeah.
And the other question was on the Phillips curve. There's a lot of debate about what is the effective employment rate, which is impacting the Phillips curve. Some people are talking about the quality of the employment, and if you have a job which is part-time, it should not be counting as much. Have you looked at this type of effects, or do you think like it's not a huge part of the debate of Phillips curve when we talked about?
Oh, I think it is, but we're trying to be like as consistent with like the literature of this standard one as possible. Yeah. Okay, so second part of the talk. So we're going to be here for a while. So the Keene model then, as you know, extends the good, I mean, in one sense, extends the Goodwin model by introducing a third sector. And originally also it didn't have many of the elements that we have here, but I'm already front loading to you the things that we thought were important to include in the model. So taxes we thought would be important, dividends, but also like what we call a kind of a dark matter type of term, like everything else that we couldn't explain. We for lack of a better name, we call it speculation. So we can talk more about what it is. It will involve things like international leakages, and it could have to do something with the government. So take speculation with a grain of salt. It's the residual. So call that the residual. Okay, and we're going to see where we're going to be introducing each of those things. So I'm not going to be spending too much time on this table per se, but it's just, you know, preview of common attractions and how the stock flow consistency works. Something else that you can look here is about interest rates on deposits and interest rates on where are loans. Loans, they don't need to be necessarily the same. So we had to look, I mean, they are not. And so we need to do a fix in the model because the Keene model only has one interest rate. So we once we had to face the data, we had to address all of this difficulties. So here we go. Let's do a dive into the Keene model, shall we? As you know, the key innovation is to say that investment now, it's not just profits times a constant like we did in the Goodwin model. It's a function of profits, kappa, and because this now can be, you know, they might want to raise external funds or they might repay loans that they made, depending on which way this compares with profits themselves. So now there's an extra variable that controls this difference, and that's the external debt of the banking sector with respect to the rest of the economy. So that's going to be denoted by D, and it's the net debt. So it's after you subtract the liabilities from the assets. And the assumption in the Keene model is that there is a constant interest rate applied to your net debt, and this tells you what is your interest payment, your interest sort of burden in each of the periods. But of course, we know that that's not the case, because the payments are really, because there's this net debt, is net what you pay on loans and what you receive in deposits. So you need to have a different time series for interest paid and interest received. And this is in the BEA and NIPA tables. You can look at that for the firm sector, how much they pay in interest, how much they receive in interest. Subtract one from the other, then you have the net interest payment, and then use this definition to define what your effective interest rate R bar would be, just simply like making the right-hand side divided by your net debt. This will tell you what R bar would be. Okay, but so now, because you have to make this net interest payment that subtracts from the Goodwin definition of profit. So now we're talking about the Keene definition of profit, which is still not the definition of profit that you see in the NIPA tables. This is the model implied definition of profit, and that's what we're going to be using here to get our first hand on how this model relates to data. But the essential relationship that you need to pay attention here is that the change in debt now is just going to be the difference between the investment that you want to make, which is given by this equation, minus the profit that you have, the definition of the profit within the model. Now, again, this investment, we have data for that, is the same investment as before. Of course, it's modeled differently, but the data is the same. This profit is not the same profit as before, but we can recalculate that profit simply by taking whatever the Goodwin definition of profit was and subtracting from that the interest payment that you make. And the question is, does that even resemble what the change in debt would be? So in a sense, I'm not even going into the three-dimensional dynamics of the Keene model. I'm just looking at one of the assumptions of the Keene model that just says that the change in debt is investment minus profit. Does that even closely resemble what is in reality? I said I'm not going into the dynamic equations, but I am. But I would skip because you all have seen that derivation, and if you haven't, I have a paper for you that you should look at. Yeah.
Actually, in the original 1995 Keene paper,
Yeah.
the interest rate taken to be a linear function.
Right. But that doesn't work. That doesn't work at all. Like we tested that, and you know that relationship is like we went back to that, and the constant works better. Right. So that's the dynamical system that you obtain, and as you know, then there's a way to calculate the equilibrium value for that, and there's an equilibrium value when that goes to infinity. So this I don't need to explain for this audience. This is the dynamics that converges to the equilibrium value that is finite, and there's an explosive dynamics that where that just goes to infinity. But one thing that I want to highlight here that makes it very different from the estimation and test procedure for the Goodwin model. Remember, the Goodwin model was stationary. So if you want to do a test that compares the equilibrium with the time average of the variables, that would make sense. This isn't. So look at the debt, for example. It goes up there and then it goes down there. The equilibrium is there. That's the equilibrium. It has nothing to do with the time average of the value of the debt before. So that test is invalid. And you know, it took us a while because we were slow and a bit stupid to realize that it was invalid. And now we just had to expand the test. So what we do now is actually look at the trajectory error for the entire trajectory in order to determine if the model is doing well or not.
Yes,
Yeah.
that's exactly why I asked the question earlier, you know, when you take the time series average, you do it because you know that it makes sense in Goodwin model. Now you're no longer going to do it because you know it doesn't make sense in Goodwin Keene model.
Right, but in the Goodwin model, I never took the average. Yeah. But you were talking about the assumption for the parameter k, for example.
Yeah, right.
And that was just a parameter assumption. Now, of course, yeah, one of the tests of the Goodwin model that we applied before is taking the time average of the state variable. And you're correct, that test made sense there, and it doesn't make sense here. Okay. Now, the first thing is we need to come to terms with what is private debt. And Steve Keene likes to use the BIS data set. And I know that many people who looked at those models also like to use the BIS data set, and we started using that. But if you look at the explanation for their time series, they have you know, debt of the private sector, they have debt of the government sector, and the time series that people tend to focus for this is the total debt of the private sector. Total credit captures lending from all sources. It also captures lending relationships within the same private non-financial sector. Most importantly, and that's highlighted by me, not by them, within the corporate sector. So in other words, it's not what the Keene model is about, which is the debt of the private sector vis-a-vis all of the other sectors. So if there's intra-sector debt that's added to this time series, because the BIS is interested in something else than the Keene model. They want to just see, you know, what is the overall level of debt for the firm sector, even within itself, because they think that this creates instability and so on and so forth. That's perfectly valid, but it's not the time series that we need to look at. Right, and it makes a big difference because it makes it larger than it would otherwise be, and the changes in that are also larger. So the first thing you need to do is not to use that. So what do you use instead? Unfortunately, the BIS doesn't have a netted version of that. I've been talking to Bill White in Toronto over several rounds of beer, and at one point I will convince him that he should go back to his pals at the BIS and redefine the time series if we want to do this, but haven't been successful. So we had to do it by ourselves, but it's not too hard. So you go down to the financial flows from the United States, and you look carefully at the assets and liabilities of the non-financial private sector. And what you do is to look at, you know, the loans as assets minus liabilities issued by the private sector, and the M are just what they hold as deposits in one type of financial sector, and what they hold as deposits one type of sector and deposits of another type of sector. So not going to get into too much detail here. The explanations are all in the paper, but this is what we debated many times, you know, what to include, what not to include, but this was kind of the cleanest, this is the end result of a lot of discussion on how to define we thought that this is what conceptually most resemble what the variable D in the Keene model is, and more specifically the variable L and the variable M in the Keene model. And then define D as the difference between these two. So that's the net debt of firms to the financial sector only, not firms of that to other sectors and so on and so forth. So you need to spend a lot of time with the BEA spreadsheets to understand what this is. But if you have if you disagree, we can discuss offline, and I would be happy to hear your views on that. But accepting that, which we think is correct, then what we had to do was, you know, if we want to test the basic model is a model in real terms, it's not nominal. So first you need to remove so this was for nominal loans and nominal deposits. So we had to turn them into real by dividing by the proper GDP deflator. And then we have nominal lending rates and deposit rate that we can get from the OECD data set. This would define this nominal implied effective rate for the Keene model, which would then transform into a real rate by subtracting from inflation. So we follow all those steps, and now you have all the elements for the model. Very well. This is the data that we have. So there's nominal lending rates, nominal deposit rates, and then we can calculate what this RN is going to be, is the red one. It's very close to the lending rate because the deposits are a small component of that, but it's not exactly the same as the lending rate. And then when you subtract from inflation, you get the green line. So that green line would be the interest rate in the Keene model, which then in 2012 decided that I would only consider the constant one, because we did some preliminary statistics of this one correlation with the level of debt, and they came out completely the wrong way. so we didn't think that was good. So we said, okay, let's just start with the constant one. So this we're going to estimate by the average in there, but later we're going to have a modification of the model where it's not, but it's not the version that Steve proposed. It's a different version of variable interest rate. Okay. Yes, it's a version that we thought has better statistical fits to the data. Yeah. You had to wait. You gotta be patient. It's so we had the Goodwin model that's version 0 of some of the tables I'll show you, and we had 5 versions of the Keene model, and the nominal interest rate, variable interest rate, corresponds to version 4. It's just one before what we call the ultimate Keene model, which you're gonna see soon. Okay. Investment. So this is the investment as a function of GDP you can get from the data set. This is the profit rate as defined in the model. You can also estimate that from data. Those are the cloud of points that you get there for the United States. There are different clouds for different countries. We did that for different countries. The estimate for the United States turns out to be particularly good in terms of properties of these relationships. For other countries, they're not so good. The coefficients are not significant. Sometimes it even goes the wrong way, that the model assumes that the more profit you have, the more investment. And my co-authors are saying, but what if we have the opposite relationship? Then the model breaks down. It doesn't really break down. The trajectories are going to be weird, but the model, mathematically, the model still makes sense, but still. So that's the estimate that we did for the investment function. Now, and then we test it. We test the model just as before. So we got all, yep.
What's the function? The kappa function?
It's a line. Yeah. It's a linear function. It's a linear regression. Yeah. So we are just saying, just in the way that we did yeah. So this function here, we are now saying it's linear. And
what you wrote in the
no. Yeah, but in the same way, we also didn't use a linear Phillips curve before, and now we're using that. So we wanted to just do a very simple, just to see what it would look like. Yeah.
I probably remember it badly, because I haven't checked out the Kimbol's since.
Yeah.
But there's a condition for the existence of the different.
Yeah.
And one of them is on the second derivative of kappa, probably.
Not really. No. Yeah, it just has to be increasing. So this is a linear one. That's yeah. But that was not for the interior equilibrium. That has to do with the infinite equilibrium, and it's for just so that you can calculate the Jacobians.
It's going to be interesting for us because it's been observed that.
Right, but you see, that condition is for this range here, and we could as well just have that and then cap it. So that's what makes the model mathematically consistent with what I wrote in that paper. Right, it doesn't matter what happens right around where the observed points are. You could just say it's linear, and then if you want to have an exponential and capped in there, you can do that. It's not going to change that fit, right? Because these are not observed points. Nobody has seen profits at the 80% range. Nobody has seen negative profits, so it's not going to change the fit. So you just assume that the function has whatever shape you want in those ranges to match the paper.
So just because in what Q model is supposed to model, the Minsky financial instability.
Yeah.
I think that is in the literary writing. One of the key explanations for the instability is how the investors or the lenders will get overexcited.
Right. But what do you do when they don't, right? So I can't just believe in Minsky because Minsky said that. Like, this is what the data is saying. No, you want to test with the actual data. You don't want to force a relationship on the data just because Minsky said that, right? And if you don't see the relationship that Minsky was saying, well, too bad for Minsky. But the model can still be consistent with that because the model doesn't really depend on the interpretation. That was a particular interpretation. Huh?
I think that you can have some exponential effect on the function.
You could for the part of.
You have to be continuous derivative everywhere.
Well, you can smoothly paste a linear function with something that saturates at zero. They're like you can do some exponential pasting in there. You can make it the whole thing continuous and with continuous derivative, right? The point is that what you're interested here for the data is just that basic shape of how profits change with investment, and you don't have enough data to differentiate. If you try to do, we did an exponential function, we did an arctan, we did all of these things. They all look the same in that range. You're not going to get much more curvature here for being an exponential, right? You're going to see like very close to linear anyways.
But what's the actual piece? I want to know how you will proceed or how you proceeded because what's the key models trying to explain is how crisis occurred or why linked to that private debt.
Right.
But so it doesn't explain how it is resolved. In the data, probably you can observe different phases when the economy supposedly reflects the key model also lens to
Yeah.
look at it. It could be like before the 80s, say the debt ratio was pretty stable in the UK. Okay. So a trajectory that would wish to fit would be a trajectory in the basin of attraction of the people. And but after the 80s, still in the UK or anywhere else, the debt is increasing on the private debt ratio. So it's rather a trajectory that is in the basin of attraction of the debt deflationary equilibrium. The thing is that we cannot in the key model. So you don't explain how you can jump from one basin to
It's a model for the entire time period. So this will come out later. We're going to talk about possible structural breaks, right? But again, the philosophy here was the same one that we had for Goodwin, right? If we assume that these parameters hold for that time, plug that in the model, does the model generate trajectories that look like anything like the real world trajectories, right? And we are considering now structural breaks, and they do make some amount of difference. But now the point is, okay, where they are, you cannot put them by hand. You need to detect what the break is. Do we have enough data to identify a structural break? Is it a structural break only on some parameters? Is it in all parameters? So that's a work in progress. With
so it's also that you look at like
Yeah.
type of
Yeah.
from given period.
Correct. Not the trajectories, the underlying parameters, because again, we don't fit the trajectories. We fit the parameters and we fit them to the model and see what the trajectories are. Right. Okay. Investment. That's all that was needed for the basic key model. Was the same Phillips curve as before, and then investment. And then, so this is the same data that we had before for the wage share. Okay. And always the blue line is the Goodwin model for comparison. So this was the Goodwin model there. This is the Goodwin model for employment. This is the data for employment. The red line is the Keene model for employment. And this is the new variable, which now here you see the debt ratio. And here you see what the model implies for the debt ratio. It's going down, it's going negative. Why is it? Because, so, okay, try to guess why. What's the fundamental relationship that doesn't work?
Here mostly with a kappa very non-slopey.
You don't have enough investment.
Yeah.
Okay, but you cannot do anything because that's the data. The investment is not much larger than the profit that you define in the model. It's the same problem as in the Goodwin model. That's without the K. But now we want to correct that in better ways than the K, because one of the criticisms was, okay, but this K doesn't need to be constant. Now we have a more sophisticated model. So let's make that correction more sophisticated. But it all boils down to the fact that, again, remember that gap that we saw in the Goodwin model? That's profit, that's investment. We're going to have the same problem here. Even if now profit is a little less, because now profit reduced by interest is still much larger than the investment. So if in the model, in the data, your profit is much larger than investment, when you estimate and put the parameters, what you're going to see is the debt actually going down and down and down. You're going to be repaying this debt. But in reality, you don't see that going down. You see that continuing to increase. So we need to turn around and correct that relationship. So that was our first motivation number one. So here I'm going to propose fix number one. So I think Paul had a question.
No. Yeah. So my question was so you reintroduced shareholding explicitly in the stock.
Not yet. This is the straightforward model.
Okay.
This is just the Keen model. Just this one.
Okay. No, it's just I saw it in the.
No, it was preview of common attractions from there. Yeah. So the first fix to the model that we did is like, okay, obviously they pay taxes and they pay dividends, right? So this is what the relationship was, just investment minus profit, but profit is just production minus wages minus interest. So now we're going to say that we're still going to have that same definition of profit, because that's going to be what is in the behavior relationship. We're going to say that remember the investment function is a signal for how much the firms are going to invest based on the variable that are observing. And we tested that again. So we have an extensive table of different regressions where we modified that variable. We introduced different explanatory variables for investment, and it doesn't get better. So that kappa relationship, the best that we can do was to use the original variable in the Keen model. So that's kind of good news for the Keen model. But the problem is that the dynamics is wrong. Not the kappa relationship. Again, that's just a statistical thing, and you can check which variable explains it better. And I can show you the full table. The original definition of the Keen model still holds better, because you introduce these other things, and now you need to say, sure, there are more explanatory variables, there are more parameters, but also you have to be penalized by the fact that you have all this external variables. So that doesn't work that well. But the dynamics is wrong. So we corrected for the dynamics by introducing those terms. And now, of course, T is corporate taxes, and we have to make assumptions here. So we're assuming that it's a constant times the GDP, and then we estimate that constant in this way. You could say, okay, well, let's make a variable tax rate. Sure, you could do that, but we didn't. So we wanted to see if only this would improve it. Dividends, again, the dividend that are paid, we are saying that it is one constant times retained profits after tax, plus another constant times just GDP. And again, this was the variable this was the fit that allowed the best statistical results. And then there's this sort of a residual term, speculation, and we played around with different forms for this. A Minskian thing, it has to do with the flow of money coming in, flow of money. Again, the thing that explained the data the best was just a simple constant times observed income, right? So I'm omitting a lot of intermediate steps. I'm just giving you the final product, but we extensively tested like several variations of those things. Okay, so this is what we call the gap correction. Okay, so D dot, the little d dot, can be calculated from the change in debt divided by, so it has, well, you know what it is, but in order to compare with this other time series, it's better to plot like D dot divided by Y, because that just normalizes the absolute change in debt, right? So I wanted to the change in debt and normalized by the GDP, because all the other things that I'm showing here are investment normalized by GDP, and then taxes normalized by GDP, and speculation normalized by GDP. And I want to know where they are. So the first thing you should see is that this is the actual, the black line is the observed change in debt, normalized change in debt. The one from the Keen model is the red one, just like in the Goodwin model, it's too low. Like investment minus profit would be just too low down there. So what you have to do is subtract more stuff from profit, because if you subtract more from profit with the minus sign, it adds, and then you keep moving up. So the first thing we did is add taxes. That closes the gap, so it makes the model a little bit better, but not entirely. Add dividends, that closes the gap. And again, this is with the data for dividends, what comes from the national tables for dividends, closes the gap, but not enough. And then there's the stuff that we just said, we don't know where it comes from. We just want to see what is the thing that now best closes this gap. So that's the speculation. And then of course, now with that term included, you have something that it's on average where that change is, because we define that term as the residual. So is whatever the other series are plus the residual, it brings it back to the level where it should be, but we just don't know where that is. So that's our dark matter, if you like.
It's just
With a room full of physicists, I'm being provocative by saying that it's dark matter.
but I like if we expand the analogy here, the government is getting tax money but not reinvesting it. So in one way, it's an explicit black hole, but we can look at.
Yeah, but remember that this model assumes assumes that the government spending is circled back to the private sector, so it doesn't disappear, right? It's a closed system. So whenever in the real data there is government spending, but it's being fed back into the private sector through production. So there's a total production, total GDP includes that, right? So that money is not lost, right? And this was the case even with the Goodwin model. So the point here is how to make the whole system fit into the model. So one of the artificial things that you need to think here is that the household sector is combined with the government. The government is a subservient of the household, right? And the households are the only things that are feeding it back to the private sector via consumption. But that includes the government spending as part of consumption.
Okay. And the other thing is, in consequence, this dark matter is about 3 times the size of the government taxes.
Something like that, yeah.
It's like, yeah, it's black matter, like it's enormous. Like people are talking about the burden.
Yeah, but I like that, because exactly as you say, it gives like a quantitative understanding of what is it that we're missing. So if we want to make this model more sophisticated and add in other sectors, so this could include international transfers that are not. So this is anything that is being taken out of the non-financial private sector and reducing their profits. It comes back again through spending, but it reduces the definition of what profit is for the purpose of calculating how much the change in that should be. So one of the things that it could be is speculation, as I'm saying, because we have another paper where we deal with speculation, and it's just taken out of this and in buying existing assets. So that could be, and we think that that's a big component. So diversion, so borrowing in order to buy existing assets could be part of this dark matter. But I leave it there, you know, as a speculation of what this. Again, the purpose of this paper was not to model it, was to introduce it as a fix to the model, and see what it does. Okay, yeah.
I don't get satisfied. I want to understand how you could get such a form for the trajectory, even in the original Kin model. Obviously, one parameter that we usually assume to constant was not set as constant.
Right? No. This is just data. This is not simulation. So each year here, what I'm calculating is the amount that a NEPA table tells me that is investment of the firm sector, and subtracting from it total production minus wages minus payment of interest. None of that is model. That is all data. So this whole thing is data. Huh? Everything here is data. Yeah. But it's just saying, if I just take the model at face value, that would say that the black line equals the red line. It's blatantly wrong. You would expect some noise and stuff, right? But the model says that the black line is equal to the red line. But the data shows that they are far away, right? Of course, the data wouldn't make them equal in every point. There would be fluctuations, but they wouldn't be separated by.
supposed to use the lattice?
So I'm going to present three versions of the model. One that has taxes and dividends. So what we see is that it doesn't make too much of a difference. It changes a little bit the dynamics of omega and lambda. It is still bad for D. It just moved that a little bit from what the previous one was, if you match the graphs, but not too much. And that's because it's the difference between the red line and this blue line. It's just adding tax and dividend is not closing the gap entirely. So it's still not great. Now, if I do everything plus speculation, oh, thank you so much. Yeah. Then this starts to look better to match D. It still diverges after a while, but it starts to, pardon my French, fuck up the omega and lambda that we had it well before. Before the dynamics of omega and lambda were better, now they start to be worse. And because they're worse, they eventually, it starts well in here, but because omega and D have an influence on the simulated part of D, it starts to diverge in there. So it's like we're fixing something, but we're screwing up the other part of the model.
Just a question. The first thing is that parameter with a lot of the economics meaningful. And here for your simulation, for instance, lambda is greater than 1.
Oh, that's right. But that's because we abandoned the part of the Phillips curve that just goes to infinity in there. Sure.
Sure, that's it's why the theoretical aspect is important
Yeah.
to put it in after to see what data says.
Yeah.
To change the form of the function and to adjust it to the data.
Yeah.
It's better to keep the theoretical aspects and to fit it on the data.
Sure. So, maybe a reformulation of that after we fix all the other blatantly obvious mistakes of the model is just to refine that with a nonlinear Phillips curve. But you see that, this involved a lot of changes and simulation and go back to the drawing board and re-estimate and so on. So we're still kind of crystallizing what the final version of this should be. But the point here is, I want to emphasize, is this: we are fixing something for the debt dynamics, screwing up the other dynamics is biting us back later in the debt dynamics as well. One more modification that I want to put here before we started to look more seriously in the dynamics of lambda and omega was the variable interest rate. So we came here and said, okay, what about if we abandoned the assumption of constant interest rate? So we did it like this. So there's a nominal rate, which we now assume to be a policy rate plus a spread. And that's the one that we thought that matched the data. We are going to see in a few slides what we see by matching the data. And then, so the policy rate has to be a policy rate that we can simulate in the model. It cannot come outside of the model. So we need to be able to simulate. So it's similar to some of what you use in some of your work. So it's a policy rate that has a constant that we can estimate, has another constant here, which is the overall like long-term inflation. And then it just says that it's, a Taylor type response to the gap between observed inflation and long-term inflation. Plus inflation, because now we want to, this is the long-term real rate, and then you do that to obtain the nominal rate. And so this is the nominal policy rate. And now inflation, of course, you need to define as something that can be calculated in the model so that you can simulate, but this is the typical markup type of inflation. So the point is that everything needs to boil down to something that it's a state variable in the model, and we are doing it by having it depend on omega. And now the Phillips curve, we re-estimate the Phillips curve as something that was it's a nominal Phillips curve plus something that depends on inflation. So we estimate that parameter as well, right? Questions on this? So this is just like how we introduce a variable interest rate. And I discussed that with my co-authors for a long time because they kept saying, oh, but just make this variable interest rate a function of this and that and that. because that will match the dynamics they observe. Sure, it would, but how do you simulate forward? The moment that you stop looking at data and want to make a simulation, you need to simulate within the model. So you need to make that a function of things in the model. So this was our compromise. And I think it's, you know, consistent with some of the literature that you guys even have produced. So it's not too bad. Now pay attention to this guy here. Again, we're going to assume that it's a constant, and we have some you know, further extensions that could be evaluated for this spread here. And it's particularly one that is good for structural breaks. So this could be like when the spread of the lending rate is too much more than the base rate. Okay, and so this could be a structural break situation. Okay, so this is actual data for inflation for the United States. The red line is our estimated inflation. So namely, once you estimate the parameters of this relationship and substitute the omega in each point and recalculate the inflation. So we think that this is as good as it will get because it's smoother than the thing that you're trying to estimate, and it's capturing all the trend in it. And so, yep.
Estimates, you mean, again, it's you have some data, you take the average of
not the average. So now we are estimating this relationship. So we're saying, let's do I, so there's the data for inflation, and we know omega,
okay.
and we estimate these parameters.
Okay, just linear regression, so something like that.
Yeah.
Non-linear.
Yeah. So we estimate these parameters, and then we plug it back what the value of omega is in each point, and this is the estimated inflation. Okay. Again, we had to use the same type of arguments before as for the Phillips curve. These are potentially non-stationary variables, but we ran all the stationarity tests for every pair of variables that we do. Yeah.
Just means that you just know the data from the wage group and the data from inflation.
Why? Why?
Because you only keep the data from.
No, he take both to estimate the true constant.
Yeah.
No, I get that. And then when you do the because there you are only fitting that relationship.
Yeah.
Then you can fit the parameters, and then later when you fix the whole model, only if it's using the data of the wage share.
No, then because the wage share is a state variable of the model, so the inflation relationship will be one of the things that show up in the right-hand side of the dynamical system. So whenever there's a term that is inflation, I need to substitute by this empirically estimated relationship. So yes, I will not substitute at that point the observed inflation because there is no observed inflation going forward, right? Going forward, there's a simulation of the model, and I can simulate the values of the state variables. And then everything that is on the right-hand side of the system needs to be a function of the variables on the left-hand side. So that's the point. Yeah, okay, good.
Next question.
Yeah.
Is why you don't have information to estimate separately and you keep the same way, same approach to estimate theta P and C bar. You don't have information.
No.
Okay.
No,
So here
that's
use
the
data,
problem.
you use
Yeah,
data.
that is the defining relationship that allows me to estimate these parameters. Yeah, there's no other. Yeah, so this just says, yeah, the definition of eta P is how fast prices react to a change in wages. So that is the defining relationship. In the same way that before, the defining relationship for K was what you see in investment when you see in profit, that defines K, and then I estimate that. So this is the equation that defines what these guys are. There's no other alternative definition of these parameters. And similarly here, I'm taking that, you know, I don't have anywhere else in the model to find a equilibrium long-term real interest rate. All that I see is observed nominal rates and rates of inflation, and then I just estimate this relationship, this Taylor rule here. So there's no other magical oracle that tells me what long-term inflation is or what long-term R is. That's coming from that equation. Okay. But this was just like the sanity test to see that what we are doing just looks like what the data is. And this is for, again, the policy rate. So the black line is the policy rate that the Fed announced in each of those things. And the red line is our estimate for the policy rate. So again, we think that this is going quite well. This is the observed nominal lending, or not the lending rate, like whatever that definition that I had for the average of lending and borrowing rate, and this is our estimated one with this delta value that we estimate there. So again, you see that it's not too bad. Okay, so what does variable interest rate do for you? It does something a bit better for the debt dynamics here. It's not as constant in the beginning. It starts to look like more fluctuation. And it does better for the lambda relationship. It improves. I'll show you later in the tables, like the errors in each of these variables. This does a little better. But this is still bad, right? The omega. And remember, omega was the goddamn motivation for doing this whole thing. And it's still bad. And then, this very clever student that was working with us had the following, he was fed up one day, and then he said, look, guys, if I take the dynamics for D in the model, the D dot, and everywhere on the right-hand side for the observed period, I substitute things that would be implied by the model, I substitute them with empirical quantities. So now what you want to say is like the little d dot, does it matter after we made all those modifications? Does it, if I don't simulate, I just substitute the empirical quantities, moving forward in time, does that match? And it matches almost exactly. So we think that, we got, if I separate that equation for the rest of the system and just do the empirical quantities there, it follows the debt dynamics. And then he went to the lambda and the omega and did the same thing. So forget about the simulated D. I just substitute by the values that I know are the empirical values for the right-hand side. Does that do the same thing? And it doesn't. It just diverges by themselves. So at that point, we all sat back and said, what is going on? And then we boiled down to the most fundamental one, which was the one that had the production function in there. And it turns out that one is already wrong at their fundamental level. So what you have to do is to substitute. So the one that has the alpha, the one for the employment rate that has the alpha, right? So that one is already wrong. So what you have to do, as some of you are already thinking here, is to replace the production function with something else. Namely, for example, a CES production function. So that's what we at that point did. It's like, okay, if, forget about the rest of the model, just the equation by equation, we substitute with empirical data and it's not working, is because, again, that equation is incorrect. And then you need to go back to a more fundamental derivation of the model, just like we did for the gap in the debt level. We fixed that all completely. But now the other two equations are wrong because they depend on something that was not to do with that, was to do with the production function. So let's fix the production function. And in particular, the two blatantly wrong, now that we're between friends and we're just saying what's wrong with this, right? We knew that the debt dynamics was wrong and we corrected as much as possible. The blatantly wrong assumptions were constant debt to capital to output ratio and constant depreciation rates. This is what it does. This is what it does. Doesn't look constant. You try to make it constant statistically right on that graph, it's going to look wrong. That's what's screwing up. Yep. We follow like standard suggestions from people that do NEPA tables, the different levels of capital, and then you average types of capital with the composition. So it's a weighted average of depreciation for different types of capital. But then we check point by point, compared to what, so this is our estimates, but we also check with time series obtained by other people, and they look like that too. All right. It just so happens, just before we get that a CS production function fixes both. It will have a variable capital to output ratio, and it will have a depreciation rate that will depend on the capital to output ratio. And so that's all we're going to do next. Yes.
You when you put your CES, you have a strong relationship between U and omega. Is
Yeah.
it verified by those data?
We're going to see.
Okay.
We're coming there, right? Yeah. I'll get to that, I think. So that's the CS production function that you're familiar with. There's that assumption of rational use of employment. This is what the capital to output ratio turns out to be. Yes, no, it doesn't. We had to, now that we have a variable capital to output ratio, now we make a further assumption that the depreciation rate is a function of the inverse of this. So it's negatively related to the capital to output ratio, because we are seeing here that it is. And then, so that's an extra assumption. It's not the CES, but it depends on the fact that the capital to output ratio is non-constant, because we now want a non-constant depreciation. And it makes sense that, you know, so what is a capital to output ratio? If that's very, now I'm too tired to rationalize, but look, before we go to that, this is, yeah, exactly. So then we imply depreciations that are lower and higher. So this is your observed new, is the black line as usual, then the estimated new precisely as this estimate here. So we just take this. So how do we do this? We take logs and then estimate the coefficients. So we do this. So we define a variable 1 minus omega, and then we do a linear estimate of this coefficients here. And we find that then plug the values of omega and you obtain that. So it's exactly in the same trend as before. It's smoother than the series that you estimated. It captures the entire trend. So we think that this is pretty good. Variable depreciation rate. So this is our addition to the model. So we just say it's a constant times plus a constant times the inverse of the capital to output ratio. So now we have all of these things already estimated from the previous equation. So we just need to further estimate delta 0 and delta 1. And so this is what you obtain. So this is your, as a function of 1 over nu, not as a function of omega, but this is the final equation. Yep.
So just for estimation question, when you come at your even the various one, A bar,
Yeah,
and B bar, and so on, and etas.
yeah.
How do you estimate it? You have information from?
No, this is only coming from this equation, but fortunately we don't need them separately. It's okay for us because they all come together. So yeah, we get something like there's an identification problem for each of them,
Yeah.
but we don't need them separately.
What you put for A and B?
You don't need A and B separate. All you need in the model is the new. So you redefine. I'm just using A and B because it came from the production function, but I might as well here redefine like B over A and call it something else, which is actually what we call. And then I just estimate this other thing and the 1 over 8. And because I don't need this whole detail thing in the model, it doesn't enter in the model. What you need is this. So once we estimate the appropriate ratio, which can be identified in the data, not them separately, I don't need them separately.
What you put for A and B?
I don't. I redefine this as C. So call.
Okay. You don't need.
Yeah,
okay.
exactly. Yeah. So that's what I mean. I don't need them separate. I only need the correctly identified combination of parameters.
Okay. Now, when you go to the next equations, you have 2 other parameters, delta 1 and delta.
Right,
0.
because now I just put this as to expand it, but I don't need that either because I have values for 1 over nu. I have empirical values for 1 over nu, so I can estimate the delta 1 and delta 0 from the 1 over nu.
Theoretically, you have some uncertainties from estimation of C.
I
Each
could,
time you change C, you change delta and delta 1, delta 0, so you change it.
but we are taking it as, as close to the data as possible. So I'm not using this part here for the estimation. I'm only using this part. So I'm not introducing this extra error. I'm using the empirical 1 over nu. And I can show you, like in this graph, I have both. I have all 3 of them, right? So this is just the regression with the empirical 1 over nu. Now here, that's the delta that you observed before. That's the predicted delta if I just use the empirical nu, that's the red line. And that's the one if I use both the estimate of the deltas and the estimates of the A's and compare them with the nu. So have it a predicted nu, which is coming up of the other estimates. So
Given some clearly over-parameterized screening model. So if you want to make some prediction or something like this, you make big mistakes on this. You
what?
overfitting model.
For the simulation, you don't need to know.
Yeah.
No, but we can run all parameters and add another layer and add another layer. Each time you can say, I know this, I fix this, and I two other parameters.
No, but maybe, but this was for abundance of clarity of, how this would all depend on omega. I just wanted to make sure that it could all depend on omega later. But just erase that from there and just say, I'm estimating delta 0 and delta 1 with no knowledge of the estimate of nu on omega, just from the empirical values of nu. And that's the one that I'm going to be using in the model. Okay. So this is what the model looks like with all, yeah. Yep. Yep.
In Europe, I think
I think, yeah, I seen, yeah. We could, but maybe we'll do that over lunch. It's a bit, anything related to the dark matter is a bit speculative. So, yeah. Right. Could be, yeah. Yeah. No, so what you want to just do an estimate of the capital to output ratio versus this other identified variable, the dark matter, and not have a CS production function. That could be a different version of the model. Okay, but this is my ultimate model. You might have seen versions of this just with the CS, but not the dividends and taxes, but this is like the whole shebang. Okay, and then when we simulate that, now, it's not perfect, but at least it has the right trend. The problem that we were having is that the previous one, like the weight share goes down, and there was no way to make the Keene model satisfy this with any of the other versions because of the wrong production function. Now at least we're getting the right trend going down here. Of course, later if we simulate more, it will reverse, but we don't know what this is going to do. It could continue decreasing, but at least now we get, for the data that we have the correct fit. Neither. I'm not fitting the model to the data. I'm fitting the fundamental parameters and then seeing what the model is. And the model is giving me a trend that coincides with the observed trend, but I'm not fitting the model to the trend. Why? The red curve is just the model. It's not the fluctuation on the model. The red curve is the omega. Yeah.
Where are the fluctuations?
It's a very slow cycle.
Yeah.
So what you see.
So that's what I do.
Yeah.
It's a fluctuation.
Yeah. Which is fine.
But you don't know.
Yeah.
We do, otherwise we see the cycle. So. No, but then it's the cycle that you
It's just a very,
put on your trends. So you're not explaining what you want to explain with the right.
No,
that
also,
you have very different cycles.
Yeah.
No longer like shortened cycles as with the Goodwin model.
Yeah.
that the same thing.
Yeah, that's exactly what I say. But
Yeah,
you cannot change like that the interpretation, the economic interpretation.
How do you know that your working data are trying to understand?
It might be like longer.
Yeah.
Over 20 years.
Yeah.
You know that the model is not fine, but the data might be.
Yeah.
I agree with this, but then it becomes consistent with what was done before with the model.
No.
it's a different interpretation, but like the equation are not claiming that our cycles,
Yes.
cycles are merging from. the
Because
equation.
of the values of the parameters. So if the parameters and you're gonna like even more some of the other pictures that I'm gonna show, because this is for okay. So I should say, you never asked how I'm selecting the initial condition here, and it's a bit sloppy of you not to have asked, which because does it make sense to select the initial condition as the observed point in 1960? That's just saying that that observed point is very special. Like there's an error in everything else, but there's zero error in 1960. But this is the continuation of a model that is coming from the past. The model, the work doesn't start in 1960. So what you're saying is that there's an error in, you admit an error, it can be an error in everything else, except 1960. What is special about 1960? We just did the initial simulation in there, right? So we struggle with that question a lot, and we ended up with finding, and so two possibilities. You take the 1960 as your initial condition as given. It's kind of the sort of minimal assumption on what it is. Or you try to adjust the initial condition according to some criteria. So one criteria is find the initial condition that minimizes the error. So, but now it starts to be like fit in the model, but only in the initial condition, not in the parameters. So we did both, and but I'll get to that in a second because that's the latest thing that I want to show you.
The low frequency that correspond to the economic interpretation of what we're trying to fix. Otherwise,
But you are already requiring a lot from the model. You're saying, I want a model that has cycles.
I mean, what I would understand, even if we manage to put it better, if it's not realistically interpretable, because
But it's what Gael said. You were saying that you were seeing here with this wage rate has cycles. What tells you that it does?
yeah, but then it works, still tells you nothing. And
Oh, it does.
Something which might help, when you put a CES in this type of model, you don't necessarily have cycles because your system is going to stabilize, and there is a value of eta under which, if you do the linearization,
easy to just take the model with the parameters for estimated and see whether that's the reason or not.
yeah, I have it clear.
Oh, it is. Yeah. I mean, and in the Goodwin model, it works like that too. Like the Goodwin model with the CES, it tends to just go kaboop to the equilibrium.
That's going back to the Newton commission. We had this discussion last week.
Yeah, but now I feel like even the parameters.
They asked me exactly the same question about the initial condition. Should we take 1960 or should we take something else? So it's very.
So what was your
I think
conclusion?
interesting in the estimation of this, because it's in dynamical system, it's clearly the questions and a true problem.
Right. But that's what I'm saying. Now, this is the only point where I say estimate from the model, because it is part of the model. There's nowhere else that you're gonna get
So
that.
for me, because I'm working with Hugo, also this kind of models, and the initial condition are parameters.
Correct. Correct. So that's what we did here. We then do an estimate of the initial condition just by minimizing the square error with some weights for the different trajectories. But that might look like, we're deviating too much from the philosophy of the model. And just so that people don't complain, we then take a convex combination of everything in an array in three-dimensional space that is between the observed point and this minimal thing. Take the convex combination, and we expanded that convex combination before 0 and above 1 just to continue that rate, so that there's absolutely nothing special about neither the observed 1960 or the estimated 1960, and see what the values are for errors and trajectories that we get. So that's, in the sense, it's a kind of a honest sensitivity analysis that we did for the initial condition, but that's going to come in a bit. Before
There's a question because interesting when you before after that when you compare the Keene model and the Keene plus tax and plus dividends, the part of the dividends, the proportion is around 10%, 30%,
well,
80%.
it wasn't that gap there, right?
Yeah,
It's because I put tax and dividend. No, the dividend is smaller than tax. Is of the same order of magnitude, but is slightly smaller.
it's around 10%.
A bit less than that, 6 to 8%, I would say. Yeah. These are the errors. So these are the L1 errors. So absolute, but relative to the point where you are. So the relative L1 error averaged over all the points for the omega trajectory, the lambda trajectory, and the D trajectory. So the Keene model does horrendous in the D trajectory. It's even worse than the Goodwin model. And for the now you got to say the Goodwin model doesn't have D. Well, it doesn't have D is implicitly saying that it's a constant D. So we just estimate the constant D and then look at the error for the curve. Even that is much better than the Keene model, because the Keene model had that horrendous trend going down for D, okay? And the average is like this. If we improve with tax and dividend, then you see an overall improvement in all of the three measures and an improvement on the average. So tax and dividend make the errors smaller. The speculation thing makes the errors smaller in D, as we observed before, but it starts to make things worse in the omega. That was the phenomenon that we observed. If you add everything that we had before, but turn into nominal variables with a variable interest rate, now you get an even smaller error in D. So this is all in the direction of fixing the dynamics for D, and it does also improve the other. So this is clearly an improvement to what was before, like variable interest rate. It's a big deal. It improves overall. If you do everything plus a CS production function, now you get the best performance, and it's finally better than the Goodwin model. So we had to work tremendously hard. It took us 2 hours of a talk to get to a point where you get something that is better than the two-dimensional Keene model. So it just tells you that the Keene model does have something to its the Goodwin model, yeah, the two-dimensional Goodwin model, and the Goodwin model is still better even in the employment dynamics, but now we are doing better in the omega dynamics, finally, which was like my quest for ages. And that is because we're not doing the Goodwin model with CS. Maybe another comparator could be here, the Goodwin model with CS. We didn't do that. We might add that to the paper later. But we say that eventually we got something that is respectable here. Now you might ask, what happens in the long term? So this is expanding. You want to see 2000 and 100, 2000. So this is your cycles. It's just a very slow cycle. We just don't know what the data is going to do. Maybe the data is going to go down and continue there. We just don't know. that dynamics eventually turns profitable, but then firms will pick, and we continue that even like to 3,000 years. It just gets unbounded oscillations, right? But you might say, okay, by that point, who cares? Like you have to re-estimate the parameters anyways. We just
Makes sense. So you have a cycle. Cycle only, or even less than a quarter of the period of the cycle.
You don't have access to the cycle.
yeah, that's all the data we have. Yeah.
I'm surprised your Goodwin is not closed loop. You're slightly diverging.
Oh no, I think that this is a numerical thing. Yeah. No. This is something to do with the algorithm that is being used. And now the initial condition sensitivity. So here's what I was telling you. So this is the variation in initial conditions. So the way you should read this is that, 0 is the point that minimizes the error. So in my convex combination, I have 2 points, right? This is the point that minimizes the error. 1 is the initial point as given, no change. And then I have anything from before 0 and after 0. So that's why you see here on or maybe it's the other way around. No, this one, 1 is the one that minimizes the error, because you can see is this trajectory here, the purple trajectory is closer to the observed one, so it minimizes the error. But the point is, now move away from it and go to the observed one and expand. You can see that you now have a full range of what this dynamics could be. And yes, it does get worse in terms of comparing with the data, but qualitatively you're not seeing something that it's too crazy. But you wouldn't, because it's the Goodwin model to begin with. So these are just initial conditions in the Goodwin model. You're just moving, where in the phase space you are. So you're just making those circles smaller or larger. The question is, what does that do to the Keene model? Because we know that the Keene model has many different possibilities with initial conditions. Yeah.
Just a question. When right now you're using the profit and the reinvestment, are you considering the relative debt ratios inside it?
No.
Because it could be an interesting explanation for the K being lower, because if here you have D higher than 1, then the amount you can put into investment is lower. So if you take the Goodwin model with a fixed debt ratio, and you put your profit modified by this, you should have a higher K ratio and be maybe closer.
Yeah, sure. But yeah, that would be a further modification of the Goodwin model with a constant debt ratio. Yeah. But we didn't do that. Yeah. No, we did.
So basically, just almost you can say you have
Yeah.
Solar model performs well if you add the total factor productivity, which is with that number,
Right.
which explains 60%.
Right. Different dark matter. This is the basic Keene model. So remember, we only did this before for one trajectory, and that trajectory diverged and went down, right? And there was that purple one. Now we're doing with everything else. So you can even have with sensible initial conditions trajectories that within the observed time period go down and up again. So this is your range of things that you can observe in the Keene model. And this is for the omega possibilities for omega and the possibilities for lambda. And then I'm not doing for all the versions, I'm just skipping to the ultimate Keene model. And so yes, you do see, like, in all of these possibilities for the initial conditions. So it's not like the fact that there was that just downward trend and no cycle was not an artifact of the way that we chose the initial condition. For this sensible range of initial conditions, you see that still. But I mean, this is I'm looking at the data reasonably well. I kind of like it. It's not too crazy, not too far from what the data says. So this is sensitivity with respect to initial conditions. We're currently working on outer sample tests, so we're going to separate the data set and then just do tests for forward looking for predictions and compare with vector autoregressive benchmark in the same way that Florent did. But maybe there'll be a separate paper. I think we have enough for one paper with what was presented here, and we're going to do a separate paper. I think the Goodwin with CS would be a good idea, and maybe a Goodwin with a constant debt ratio might be a good idea. That's a good suggestion. If I forget, remind me later this afternoon. We're doing structural breaks, but there's a ton of things that can be done with structural breaks. We're going to leave that for later. And with not this set of authors, with a student back at McMaster, we're doing the sensitivity. But this now has like 20 or so parameters, right? So it cannot be a one-by-one sensitivity. So we're going to do Sobel index analysis for this total sensitivity with all of the parameters and the methodologies that are used there. And then further extensions, that's why I'm here, so I get ideas from you guys for possible further extensions. So conclusions, if we add taxes, dividends, speculation, inflation, variable interest rate, capital to output ratio, and depreciation to the Keene model, then it can beat the Goodwin model. However, the estimated model still exhibits this unbounded oscillations and the low frequency of the cycle, if you like. So this is from T.S. Eliot, and so, you know, there's the model, and then there's reality, and this is part of this famous poem that says, "Go, go, go," said the bird. Humankind cannot bear very much reality. It's hard. Real data is hard. Thanks. Are there any questions?
So the Goodwin model for the trend, because we were always putting the data only to say the debt ratio when we aggregate, but otherwise the wage share or investment share when it's corrected on the employment rate. But when we were not checking if it correctly reproduced the output. So
Why? The Y, the output Y, the product. Yeah.
Is exactly the same as it's storage. Yeah, and in the end, we have the long run.
Yeah.
In the end, we have the natural rate of. So there's also in between this endorsement explain difference.
You have the sound of the different person which is not on your computer. And can you activate your sound? I think they have some questions.
Oh yeah.
Now Hugo, you should be able to speak.
Can you hear me?
Yep.
Great. So first, thank you very much for your presentation. That's really interesting, and actually we are working on really similar topics. So thank you so much. I have a few questions, so maybe I give it to you, and then you choose what you want to answer to. The first one was on the financial data. Because actually I've been through this terrible work with the financial data of the US on the S4 and S5. Yeah. And actually I have first a technical question on why did you include the S6, which is on the households? So because when I was going through this, I just said, okay, the Goodwin model don't speak about the households. So maybe I should better use only data for firms. So this is the first question. Maybe the second is on the dark matter, because when I was looking at those data, I was just thinking that actually we clearly see that part of the debt is used to buy assets. This is why, I mean, it doesn't work. So I was wondering whether this dark matter is only this phenomenon that we can see on the data, the fact that basically the balance sheet, the entire balance sheet is growing, or is it something even something else is in it? I'm sorry, only the two last questions. And another one was on structural breaks. But actually, I think you answered that you want to work on it. Maybe the last one about your conclusion too. I think that the interest of the Goodwin-Kin model is the fact that basically, I mean, this is interesting because it can collapse basically. So this is why we study this. But when I was going through this work, I was also wondering, actually, we are looking at data in which there is no such phenomenon. And we are trying to estimate a model which dynamics is interesting only in these kind of situations. So I was wondering how, well, I mean, first, do you think that the Goodwin-Kin model is still interesting, even if it doesn't fit really well the data as we can see it? And secondly, how can we, do you think that there would be a way to use actual data with different functional forms to still have this kind of interesting extreme dynamics?
Yeah, so these are all very important questions. On the balance sheet, I have to say it's been a while since I looked at that, so I need to look in more detail. Are you around? Are you in Washington, or you're just not here?
Oh, actually, I'm currently in France, but I think I will be in Washington in February.
Okay, but I won't be here. But maybe what I can do is, so I'm here all day tomorrow. So maybe we can have a kind of private Zoom session where we go into more detail and we can put on the screen the balance sheets, because so my answer is going to be necessarily confusing now, and if people have no familiarity with that, might not be interesting to them either. So we can look into that. But this related question on the dark matter, I don't think that has to do because we do look at assets and liabilities. So we try to make a point that we are looking at the net indebtedness of financial firms. So not only looking at assets. And then the final one is it still an interesting model? Well, that's up for debate, I guess. Even if it's not a model that we want to continue to be using, it's interesting to know why, right? So that's why we're doing that. But I do think that it makes makes you skeptical of a lot of the sort of easy conclusions that one can get by so what Steve had in his thesis and his paper and what I had in some of my papers. It was all about, the range of possibilities for dynamics that these models generate, which is more than a neoclassical growth rate model that just, don't take into account the possibility of financial collapses by design and so on. So that stage was kind of drawing awareness that there's a class of models, and we want to look at dynamical systems. We want to look at models that have multiple equilibria. We want to look at models that the equilibria had different stability conditions. So it was all in the kind of exploratory phase. What can these models do, right? But then bringing them to data is what do they actually do in the range of parameters that you have, and so that's a different question. And even if it's a negative question is then interesting, because now you move to other models. But I would say the fact that this particular model might not perform so well, that doesn't mean that the class of model to which it belongs, like what you're saying, you can change the structural relationships. You can have other sectors. Maybe it's an important thing to have the government sector there that we're not doing explicitly, right? Maybe aggregating the government sector with households is not such a great assumption. Maybe having the foreign sector will have to be put explicitly in there, and will improve the relationship. So I'm still sort of not going to abandon the research program, but yeah, the emphasis on the specific model should be taken with a grain of salt, I think.
Thank you very much.
No worries.
Thank you.
Okay, so maybe Maria, did you have a question?
No, I don't have question. I hope say thank you very much, Professor. It was a very, very nice season. Yes.
Thank you. And I assume you're not in Washington either.
And I am only in Paris.
Oh.
You are in Washington now. The people is happy
Yeah.
to have you.
Hey, thank you. Yeah. So like, yeah, it's a seminar. It's a bipolar group, right? Half Washington, half Paris. Yeah. Maybe. Hey, can you invite me to go to Paris? Give a talk there. I'll go. Yeah. Exactly for the next strike. Yeah.
You're welcome.
Yeah.
Thanks.
Welcome.
Yeah,
Yes.
I would. Yeah. But they don't work for me. That's the easy part. It's fun to go to strikes in
You can
Paris.
support external one. And
Yeah, yeah.
against the local one.
Yeah.
Additional questions online. I think maybe we might just end the seminar for now, and add some more questions as we have lunch together.
Very good.
Thanks.
Thank you. Thank you.
Again to all of you that were able to join today, and of course, thank you, Professor, for coming. And just as a short notice, the next session of the Learning Center will be on December the 15th. And we will have not in person, but remotely Professor Steve King, which has been
Tout le monde s'est mis
with us today.
à cause de la caméra, mais moi, je peux pas me mettre. Tu vois que je peux me découvrir comme ça?
Maybe see you there.
Thank you.
Maybe I'll join that. So when did you say?